LONGi has set up its policy, and now we are focusing on back contact technology. All of our future products will be coming with back contact technology. We have around 120 patents for back contact technology and around 1,000 research persons working on it. So from 2017, then coming to 2019, where we completed the mass production prototype. Then 2021, we achieved the technical breakthrough that was required. And from 2022, we launched our first back contact technology, which is HYMO 6, or commonly known as X6. So, but that product, we kept it for the commercial and distribution market. And coming to 2024, this year, we started to launch our HYMO 9, which is the N-type bifacial module. So why back contact is the optimal choice? The most important part is the theoretical maximum efficiency of the back contact, which is 29.1%. So this is the highest among all the silicon technology, crystalline silicon technology. Apart from having the highest efficiency, we have 100% light loss reduction. So as you know, in back contact, there are no front ribbons. So there are no reflection on it. So no light loss. 60% reduced current losses. So the way bus bars have been added into HYMO 9, we have achieved 60% less current losses within the module and maximum technology compatibility. So in the next slide, you can see difference between among the technologies that is available in the market. So TOPCon, obviously, we all know 2% light loss obstructed by fingers. Obviously, it's based on the tunnel oxide and 50% reduction compared to PERC. So it was a very high feat when from PERC everybody went to TOPCon technology. Coming to HGT, obviously again it has obstruction from the fingers and it has 7% light loss, and still it's expensive in the mass production stage as well. So you will find a direct price difference between TOPCon technology and HGT. But with that contact, you can integrate whether it's TOPCon, whether it's HGT, whether it's PERC, and achieve 0% light loss and move forward with it. So in the PERC modules, if you remember, when it was module efficiency was reduced to like the maximum efficiency you will get is 21.5 to 22 maximum. With TOPCon, currently even with HYMO 7, you are seeing 23.2 to 23.3%. But when we introduced HYMO 9, the module efficiency rose up to 24.4%. So we took a big leap in about 1% in the module efficiency. So as I have mentioned earlier, back contact, so there is no ribbon, but there are more important factors apart from just having front ribbon or not, which is the temperature coefficient. So as you know that in the Middle Eastern market and some part in the Central Asia as well, temperature plays a very important role. There are higher extreme and lower extremes to it. So we have achieved better temperature coefficients in terms of HYMO 9. So what does HYMO 9 mean to you? This is very important part. So key factors are mentioned and everybody knows because I have gone to your office and met you personally as well. But one factor that sometimes is not highlighted is HYMO 9 is changing. It has changed from the beginning. Like we have changed the wafer of it. So currently HYMO 9 is coming with the tie-ray wafer, which we launched 6 months ago. So it's not only one type of technology that has changed. The wafer in itself has changed. So previously what happened that all the manufacturer will have the same wafer and then different type of TOPCon technology and then place it. So we have changed the wafer, which is tie-ray. Why wafer is important? Obviously it's the core. And most of the O&M, because we sometimes forget about O&M. So most of the issues that arise in the PV plant, it relates to wafer part. Apart from that, encapsulation. This part for Pakistani market, it's a new part. So in HYMO 9, it's coming with dual POE. So usually what happens that the environment degradation that you have because of light, because of humidity, it has been reduced by using a special encapsulation. If you remember right now, I think POE and EVA is coming for all the other TOPCons. So because POE has higher cost, so nobody wants to go with double-sided POE, but with HYMO 9, we are doing that, and that's why we are achieving good numbers. So staying on the wafer, one of the important part is the maximum breaking force that is there. So we have achieved 16% more breaking power. It gives the uniformity to the silicon wafer. So it increases the current flow as well within the module. With the price dropping, this is very big issue that some of the manufacturers have started to thin their wafer. But with HYMO 9, actually it has thicker wafer than even the normal TOPCon. So it's about 10 micrometer thicker. So maximum stress is increased up to 28.5 megapascal. If you ask me why this stress is important, it's because of micro cracks. So when you are installing the module, and sometimes you have seen people placing foot on it, or there is high torquing on it, so you will get micro cracks which cannot be seen by naked eye, but it impacts your production. And with time, the degradation increases, and nobody knows why unless you do the detailed testing. Yes, so with HYMO 9, we are going with the eye welding. Traditionally, the modules have Z-type welding. So what happens in the Z-type welding is the pressure around the edges of each cell is around 50 megapascal. But when you have the HYMO 9, it's around 26 megapascal. So 50% has been reduced. And again, due to the soldering, 19% loss from risk related to soldering has been achieved. So you see over here is the open circuit temperature coefficient. It has been reduced to 0.2%. The shortcut circuit current 0.05%, and the power factor coefficient has been 0.026%. In the market, it's 0.29 right now. So what does this mean to you? It means that maximum 2.18% in overall generation has been increased only because of these temperature coefficient which we have done. And coming to degradation part, we all know that the annual degradation is 0.4% for all the entire module type, but with HYMO 9, it's 0.35%. So you are getting more energy of about 1.51% over the life period of the plant. So coming to this part where uneven radiation is there. So sometimes there's a misconception that uneven radiation is based only for when you have shadow. No, it's directly related to soiling as well, because soiling is not uniform. Soiling maybe at the top side will be low, usually because of the tilt, the bottom side has more soiling. So we did this experiment where we covered one cell up to 50%. So we saw 5% gap between HYMO 9 and TOPCon. Then we covered the whole cell. So the drop you can see is 34%. And then we covered two cells. So still we are managing 17%. So this shows and in the coming video that I will highlight is, this shows how much efficient HYMO 9 is in terms of low irradiation and uneven radiation. One more important part is the lower current in uneven radiation, which is the biggest cost during O&M. It causes hotspots in the module. So HYMO 9 is having the highest temperature of about 79 degrees Celsius, while the TOPCon has 131. So in the next slide, when the video will come, you will see the difference on there. This slide shows the summary of the HYMO 9 that you are getting. So over the life cycle of the plant, you are getting about 6.5% more energy than the TOPCon. Obviously, it depends on the project to project as well. Sometimes some of the parameters of the site will not support, so this percentage can be lower. But based on the same size, we have increased the module power bill up to 660 watt, whereas TOPCon currently is standing at 620 and 625. Efficiency, as mentioned earlier, 24.43%. Over here, you can see the temperature coefficient of 0.26. Apart from stronger low irradiant performance, and uneven irradiation. So in this slide, before playing the video, what we have done is there's one TopCon product, and we have used that energy to power a motor, which is a fountain motor. So you will see how the difference is coming. So this test is for the uneven radiation. You can see the difference in the power. So this is completely stopped, whereas Harmon is still producing. This is early morning. Oh, sorry, evening. This will stop right now. And when the early morning time is there, you can see the difference. It has started working. No. So you can see the voltage drop in the TopCon, whereas there is no voltage drop. And this is the test. So this is our testing equipment. So you can see over here, high intensity light for 1 hour, and the temperature is 79 degree over here and 131 degree over there. So if you have any question about video, I can answer it right now, and then obviously there is a session of question and answer after the complete presentation. So a summary of the comparison between TopCon and Harmon 9. First of all, as mentioned, silicon wafer type. We are using the Tyre silicon wafer. Thickness, we have increased up to 10 micrometer. Welding technology, the I-type welding instead of conventional Z-type welding. Encapsulation changes from POE and EVA to dual side POE. Module operating temperature on average 0.05 degree less. And special design, obviously, how the bus bars are connected on the back side, so it reduces the lower risk of current. Yes, this part. So over the life cycle of the plant, these are the main parameters that happens in the module. Obviously in Pakistan we don't have utility scale project that is been working for like 10 to 15 years. But usually, as per our experience, we have seen delamination if the working temperature is too high. That's why we mentioned that the Harmon 9 has lower working temperature. Corrosion. So again, in this part, the encapsulation plays an important role. Mechanical braking. So high strength wafer can reduce this issue. Discoloration. So again, it comes to the encapsulation part when the humidity or moisture can enter into the encapsulation, then the discolor will happen. We have seen the yellow usually modules. And ribbon cracks. So ribbon cracks happen because of the stress on the edges of the module. These are the percentage that we have. So 19% is because of corrosion, braking 19%, deceleration 12%, ribbon 8%. But highest one is delamination. So it's not only just we have switched from one product to another. Once you have the double side POE, so 42% of that losses that is currently happening due to the O&M condition can be. So for the dimension of the module, we have kept the dimension constant 2382 into 1134. This dimension we think is the best in terms of installation because of the weight. It is only 33.5 kg, so 2% can install it. If you go with the higher size module, you need at least 3% because it goes up to 38.5 kg. Transportation, with this size, about 720 module per container can be transferred, but larger module size, 594 modules per container only. And we all know, due to the political situation of the world, transportation is a big variable, transportation cost. So this is important part over there. System compatibility. So when you are installing trackers, obviously, when you have lower weight, the cost of the tracker is different as well, especially in the high weight condition. Module reliability, this dimension has been working in the industry for a long time, so everybody knows that this reliable. And for the manufacturer, this size is like for us, we don't have to upgrade our factories to reach to the new size model. So HYMO 9 is coming in two models. One is the 72 cell up to 660 watt, and one is the 66 cell. So compared to like why 72 and 66, it depends. Like for example, for floating, 72 cell performs better under certain circumstances. Sometimes for the when you need longer array, 66 cell performs better. So obviously this was the feedback we got from the industry, and that's why we have launched HYMO 9 with both of the products. So developer can choose whether they want to use 72 cell or 66 cell. So we have done one internal simulation in Spain because it's not written over here, but we have secured almost around 1.6 gigawatt of orders for HYMO 9, and most of the orders are coming from Europe because over there the land cost is the big issue. So we have done this analysis in Spain in the same land area. So apart from like higher install capacity, instead of 121, you can install 127.7. So land cost has been decreased by 5%. Inverter and other components have been decreased by 5% and 5% module installation as well. So this is our simulations result that in the European region, especially in Spain, you can the LCOE is around 2.7 cents lower. For Malaysia, floating 1.8 cents lower. For China, 1.44 cents lower. And again, fixed track. This is both are fixed track. That's 1.6%. That's why we promise lower LCOE when you are using HYMO 9, because it's not only about the power bill, it's about BOS saving as well. You save in cost, you save in installation as well. This is the last slide. I will not take too much time. So we already have shipped 11 gigawatt for the back contact technology. Obviously, you know that HYMO 6 is there, and we are guaranteeing our partners that we will have 38 gigawatt of mass production for back contact technology, which includes the HYMO 6 and HYMO 9. And depending on the requirement, we have planned to go up to 70 gigawatt. Thank you. And if you have any questions, please feel free to ask.